My name is Olena. I'm very happy to be here today. In my daily work, I deal with a lot of data, a lot of streaming data in all forms and shapes. I actually work at Confluent, and we stream real-time data, we process data, we govern, we store, we do a lot of serious stuff, usually like banks, like transactions, fraud detection, health institutions. But today I wanted to do something a bit more fun. And in this talk, I wanted to combine streaming data with some of my favorite games, which is called Stardew Valley. Actually, based on the number of hours I played this game, this is definitely by far my favorite. How many of you actually heard about Stardew? Oh, nice, cool. For those of you who never heard or never played, don't. You will save a lot of hours of your life. But if you play, you will enjoy it a lot. So we are going today to take the game characters out of context. We will put them onto the map in the village and make them talk to each other. And while doing this, we will use different technologies. So I work a lot with Apache Kafka for streaming data, also Apache Flink for transactions, for all the processing, and then OpenAI, and we will use some RAG and vector search there as well. And before we do it, I wanted actually to look on the different papers which exist right now and what exactly inspired me to do this particular demo. So when actually recently I started looking, I wanted to catch up with latest in LLM agents and kind of what is built. I found a nice GitHub repository with a lot of references to the papers. By the way, all the links I'm sharing, I will share with you through QR code at the end. But anyway, so this GitHub repository, I'm like, okay, I checked the latest, and then I found another GitHub repository, and I realized that the number of papers which are published on LLM agents are just countless, but I will share with you the ones which I found the most interesting. And the first one which I run into is called Generative Agents, Interactive Simulacra of Human Behavior. I'm still not sure about the name and how much I like it. However, the paper is amazing, and it was published around 2 years ago. And first I spotted a demo where the creators of the paper, and this is collaboration between Stanford and Google, they created a village where around 25-30 villagers live, and each villager has kind of a brief information about them and the relationship between people, but the rest they create on their own. And they have current states. In the village they can interact with different objects, and generally they create their own world around them and their own identities. So I thought it's pretty cool. Actually, it's built on using Python. The repository hasn't been updated for the last couple of years, which is a bit sad, but there are other implementations of this repository, which I will mention a bit later. So it's really a pretty cool thing. And what is also interesting is that while they were building, and this is the paper itself, they actually created a lot of, in my opinion, innovative pieces. So they added parts such as, in general, to environment to interact, different locations. They added schedule, memory, and in particular, they added thinking process. We will come to that also in a second. So look how it looks. The map itself contains a lot of different areas. So there are houses where those villagers live. There are parks where they can actually meet each other. There is college dorms, so there are younger villagers, older ones. They all have their own kind of goals in life and so on. So and each of the villagers, they have the routine. So it starts, they wake up, they have kind of a schedule, even though the schedule can actually change depending on whom they meet and what they do. And the part which is the central part of this, I think, paper can be described in this particular diagram. This is kind of their thinking process. So each agent can actually perceive what is happening around them and build on top of it. So they start perceiving like they touch an object, and they can do like go to a fridge, open the fridge, or they go and read a book. But then all the memories stored in the memory stream about that particular event, but not all memories are relevant in any given moment. So, for example, they later meet some other villagers, and it's like the fact that they ate something for breakfast is no longer relevant. But some memories that they were talking to other villagers about this villager is more relevant. So they perceive, they can reflect on what is happening on some regular intervals. They actually go and reflect on what they were discussing with other villagers, or what they were doing. They can plan. They use their schedule, but then they also apply some modifications according to what they heard, and then they act. And actually, like yesterday, I was watching the recording. This was happening a couple of days ago. AI engineer, and then they were talking how Gemini thinks, and then that between the request and response there is this thinking process. And I'm like, okay, this is still kind of a novelty, and we right now work more with those models who can iterate and take some time to consider and think something. But in that paper, which right now I'm showing, they actually also introduced that concept, and that was kind of still at the start where we had GPT 3.5. So yes, so memory stream looks like this. So for example, like, I'm not sure if it's visible, like desk is idle, bed is idle. So they kind of notice everything which just happens around them. So they notice they are in a room, what is happening with other objects. And then when they try to retrieve the memory, and this is the screenshot from the talk by one of the creators of this paper, they kind of try to retrieve the most relevant memories from their storage, from their brain. And here they look at the recency, at the importance, and at the relevance. And even though this is kind of looks pretty simple, in the papers which I read after that, this particular idea mentioned and reused multiple times. So then how it works? So we take the memory stream, and then we look at what was happening, and we calculate that retrieval score based on that formula. And then, for example, Isabella here says that I'm looking forward to the Valentine's Day party that I'm planning at Hope's Cafe. And the kind of identity of those villagers is built on all the observed rounds. For example, they're observing that, for example, here's from Klaus Müller, and he is reading about urban design. He is reading some other papers. He's in the library. Then he does some reflections, and it goes kind of bottom up with some observations, but then he reflects, he plans, and then in the end, at the top, Klaus Müller is highly dedicated to the research. So he creates his own identity by spotting those things and then kind of creating some perception around it. Another idea which I really like in the paper, which I try to implement also later in my project, is that they have this set of the villagers who are going around the city, interacting and doing just their stuff. But they actually can also interact with each villager individually, and kind of they pretend to be like interviewer, or like just put some seeds in their identity, and they put a seed into Isabella that Isabella wants to organize a party. And then they waited for 24 hours in the life of those villagers, and they kind of observed, would Isabella convince everyone to make that party? And she actually did. She didn't manage to talk to everyone, but she talked to some people, and those people spread the idea to other villagers, and in the end they also separated the labor, who is bringing the balloons, who is doing something, and then they came to that particular place for the party in the evening, with the exception of some villagers. But still, majority came. And I mean, this is a real life situation. Not everyone will be able to join for the party. The GitHub repository is super interesting. They store a lot of details about the positions also of the villagers. So if you will have a chance, definitely look at that. But in generally, I think that this repository, this paper, even though it is like 2 years old, for me it was like the eye-opening, and at that point of time, something super impressive. So I started experimenting with some stuff on my own right after that, and I started also adding a bit of this thinking process. For example, I built a Mafia game. This one for 3 players, even though like you can put how many players, this is just for them to fail fast. But generally, so in Mafia game, you have to think not only what you are saying, but also kind of consider what other players are saying and kind of suspect who of them is Mafia and who is not. And here, for example, one person, Olivia, says something, and then Vincent and David reflect on what Olivia just had said. And I guess Vincent here is a Mafia. And then actually Mafia, he killed Olivia. So the game was very short, but like the more players you have, the more interesting interactions there will be. One thing I learned with Mafia game is that if Mafia starts the game, most probably Mafia will win. So if it's LLMs, and maybe this is changing right now with more powerful LLMs, but generally like they influence each other quite strongly. So if Mafia starts, Mafia can influence everyone, pointing to, for example, Olivia, that Olivia is Mafia. If Olivia will start and she will point to Vincent, to Mafia first, then Mafia will lose. So then one of my colleagues created kind of a planet where some aliens live, and they also talk, and also they have live feed, and they can interact and remember stuff. So one of my next demos was to use LLM and to use the PubSub to exchange the messages between different agents and interact, and then store the data in Apache Kafka topic, later to summarize that information and reuse for future conversation. So in a way that then every time those aliens, and I was still using the aliens, they live in the land of Hippola, and there are so many conversations about flowers and caves and so on. So LLM is very imaginative if you give some kind of crazy scenario. So and then they meet again and again, and they build upon the last conversations. But at the point of time when I was playing with this, and it was like maybe a bit less than 2 years ago, we still had GPT 3.5 or a bit later versions, and the context window was pretty limited. So we had to be creative. Even right now, I think we have limitations. But at that point of time, they were way more significant. So we had to think how to make sure that all the relevant memories are retrieved. And for this, I was using semantic search. So I'm using vector search for each of the memory which is stored between the aliens. I would store the vector of that memory, and then I would retrieve based on next conversation. Whenever they were talking, I'm like, oh, you're talking like last set of phrases like this, so I would retrieve this memory, which is kind of something which was discussed in the past. And in this way, they could interact and bring a conversation every time I would put them together again, next and next stage. And in the end, my aliens, they were going on walks, and like I had Judy and Nick here, and they were talking, interacting, and all of that was with Apache Kafka, with OpenSearch, and with Volky at that point of time. Then there was another paper which I really liked, and this was the same creators by June Park, also like Google and Stanford. And what they did, they took human participants, they interviewed those human participants, and they created agents based on those participants. And then they interviewed again with different set of questions the actual humans and the kind of fake humans, the agents. And they kind of showed that the the responses were more or less a match. So it is possible to emulate a human with this particular approach. When you interview, you create a corresponding agent. And it's also quite interesting. So it's possible like to talk with an agent, and the agent would be pretending to be that human. There is also code which you can run, though it has only one real profile, because they try to hide the private information of the participants. And the one real profile is actually by the creators of this paper, this June Park. And this is how you actually store yourself for the future. I mean, if the paper survives the time. Then there were some other cool implementations. For example, this Voyager, where LLM actually uses to teach itself and goes like the lifetime, and it can grow the skill library, like build, for example, a house. It can actually has improvement loop, like learn how to work with some tools. And it just kind of goes, fails, sees errors. If something doesn't work, it goes back. So it actually tries not to use any of the help of the humans. Then there was another one. This actually was totally imitation of this generative agents paper. They also created a small village. Where the villagers awoke, and you can actually join that and be one of the villagers who interact with other villagers. And I think this is, well, maybe I have some more. So OpenCity, they actually went, and the key point of this paper is that they try to introduce not only like 20 of the villagers, but they try to introduce thousands, up to 10,000 villagers together. And the challenge here was that if you try to send so many requests to LLMs, it's actually pretty slow. So they did this group and distill prompting approach, where they actually combine all the requests to LLMs for their thousands of villagers together and made it within like less requests. Couple of more which I wanted to mention. There is Tiny Words. This is by Microsoft. They created Tiny World and Tiny People within this Tiny Troop library. And this is used for also you create your people, and then you say, okay, we need to brainstorm how best to write this advertisement for a flat. And then they also have the same process of talking to each other, but also reflecting. Yeah, thinking is here, like it's light green. So they talk, they think, and then they talk again, so they process it. And a couple of more papers, which I think quite interesting. The memory itself. This is a fresh paper from May this month. They combined and they looked from different types of memory, because we have long-term memory, we have short memory. We need to also to forget old memories and gain more memories with the time. Something also interesting and relevant is reasoning models. And this particular paper works on the reasoning models, where I think we right now use more and more reasoning models so that we can have this chain of thought. And the model, even right now, like I'm using most frequently OpenAI, and I see how the thinking process works, and step by step it tries to gather more information and build the response using those additional resources. So often, actually, what I notice, we no longer even try. So we train, of course, the models are trained on more and more data, but at the same time, it makes a lot of requests outside to the web to bring that information within that thinking process, and goes and Googles for not really Google, but searches for something when it needs additional information, then comes back, thinks about it, and then maybe searches for something else, and then comes back and gives the answer. So there is a lot of research and a lot of cool direction, and I think I was looking mostly for something which is actually kind of fun. So now let's build the village. Let's build something fun. So I took Stardew Valley here because, first of all, I really like it. I was listening to soundtrack of Stardew Valley when I was building this. But also they have already kind of a village. They have all the history behind every character, and I could just copy paste that into my project. So here is Louis, and Louis is the mayor of Pelican Town. So I have some information here. I just copy pasted it. It actually probably needs some cleaning, but I think it's kind of was good enough for me. And then also because there are so many additional like add-ons, I could find all those, do we call them sprites? I think the kind of the pictures of the villagers, so I could use them on the map, and I didn't have to kind of spend a lot of time on creating those on my own. So at the center stage, I had a villager, and also I had the world. And then I was using the animation frame of the browser as a loop of the game, which was triggering the movement of the characters. So that part was kind of surprisingly easy. So I needed to see which direction they should move and which sprite I should show during that time. But they started working. I was super, super happy. I didn't, so for my experiment, I decided that they shouldn't go to the houses. There are different approaches how you can actually navigate and show them where they can go, where they cannot go. I just kind of created the rectangulars around objects where I didn't want them to go. There's like red zones, red rectangulars, but the rest they can walk around. So that worked fun. So it was pretty fast and well. Next, I wanted to come to the point that they start interacting with each other when they are next to each other. And they move on the map, so they change constantly their location. I need to calculate where they are at a given point of moment and if they are close enough to each other. So for this, first I sent data to a topic, to Apache Kafka topic, which is called villagers locations. How many of you are familiar with Apache Kafka? We have maybe 50% of. So Apache Kafka, I mentioned at the start of this presentation that so Apache Kafka is mostly used for quite serious use cases like banking, industry, insurance, and so on. This is a platform for streaming data. It's used in microservices, and you just quickly move real-time data across your applications, whether it is like microservices, which is a very common use case, or maybe IoT devices. The whole idea is to get the real-time data as fast as possible. And the whole design of Apache Kafka is that it's kind of, we can think as a pipe which can get broader, like bigger or smaller, depending on how much water you have. So we it looks like this. So we have producers who bring the data, so some data which is generated. For example, for us, it will be the villagers who are moving on the map, and they are sending every second or more frequently their information about their locations to Apache Kafka. And then as consumers, we will read that location and we will calculate the distance between those villagers. So Apache Kafka does the process. It tries to make the movement of data as fast as possible by thinking how many producers, so you will think how many producers, how many consumers can have. If you don't have a lot of data, you can decrease the number of consumers and save the resources. And this pipe it's not just one pipe, it consists of different partitions. And those partitions can be populated in parallel. So we try to kind of make the movement of the data as fast as possible with Apache Kafka. But for our use case, we send data from each of the villagers. So here I have the data, for example, from Sam. I have coordinates of Sam and timestamp. And each villager will produce their location. I made it 1 second. I could have made it on every loop, but I decided, okay, it's like 1 second is enough. And then I needed to calculate when they will be going closer to each other, because I needed to emit event on that point of time when they approach each other close enough. So for that, I was using Apache Flink. How many of you know Apache Flink? Okay, so we have maybe 6 people, 7 people here. Great. So Apache Flink is for data transformation, for real-time data transformation. Again, when we don't want to wait. Actually, Apache Flink is the one which is used for fraud detection usually, because it can really quickly look the data, the real-time data, as well as reference historical data from the databases, combine it together, do some computations, and then bring the data to either streams or whatever storage you or applications, whatever you need. And it works pretty fast, and also it can be, because it has some snapshots and some others, so you can have exactly one semantic. So you can make sure that all your events, all your real-time data was processed exactly once by Apache Flink, which is quite important if you're talking about, again, banking and health insurance and so on. So anyway, for us, I looked in those villagers. I took the villagers, and here, like in my topic, I have those 20-something villagers, and then I computed they are based on the X and Y coordinates, how close they are. I only looked at them if the difference, there was a difference in name and only one direction. So for example, if I look at the Louis and Judy, it will be Louis to Judy and no Judy to Louis. And that's why I have this kind of minus sign there. So anyway, I compare all of those villagers to each other, and I do that comparison with an interval of 1 second and check how close they are. And if they are close, that are close value will be true. So I send the data to Apache Kafka, and then I actually can determine how they close to each other. So they have this right now rectangular boxes around them. And in the corresponding topic, when they are close to each other, I meet the events. So they like there is a close. Here is Boolean false, so they are not close. But if there is true, then I know that, for example, Robin and Sebastian will be close to each other, and that would mean that I can start the conversation. For conversation, I was using large language model and Apache Kafka, so I was sending data to Apache Kafka. It was reading the data, and then at the same time, other villagers were subscribing to the same topic, and I could read whenever message comes, and they filter the phrase which is sent to that particular villagers. They could react to that message. So they started talking. They started talking a bit too much. Again, they were using some information from the game itself. So there's that kind of history. I was super happy. Though they were talking way too much, so I had to add kind of a cool down between the conversations so that they don't really like constantly talk, but they wait for at least 10 seconds between starting a new conversation. Also, sometimes they pass each other and they already move away, or at least one of the villagers, but another starts the conversation. So I also added kind of aborting the conversation, so it was looking a bit less messy. And the conversation itself was also going to Apache Kafka topic. For example, here Linus says to Louis, I heard about Penny and Emily expressing something. So they could communicate to each other. Then there were some other things which I found a bit annoying. For example, if you have 3 villagers next to each other, they can start talking like a circle. So they don't really have, of course, they don't have a common conversation because I didn't implement that. But it can be that, for example, Emily talks to Louis, Louis talks to Linus, and Linus talks to Emily. So it's kind of like a mess. So I'm like, no, like we don't do interruptions. We just only 2 villagers at a time can talk to each other. So that was helpful. Then I had to improve prompts, and this is my final state of, like, not final, I think it's final state of prompts. I said that your goal is to reply as a particular village, keep it short, friendly, in character, avoid shallow small talk, formal conversations, only give a reply, no explanation or metadata, meta comments. Because they often kind of, the LLM will return like, I would say to Judy this. I'm like, no, you should just give the response. So a bit of play there, and it was better. Then it was time to add long-term memory, because I wanted actually to then introduce some goals, and I needed kind of them to remember what they were discussing. And for this, I was using RAG. There are different approaches right now. Right now, we're also using some kind of cached-based approach, but RAG was pretty effective for this one. How many of you are familiar with retrieval augmented generation? So, okay, quite a lot of you. So, but if you are not, retrieval augmented generation is actually quite simple. When we can store some additional data, or we can request some additional data from some APIs, or store it in a database. And the idea is that we get additional context from those sources. It can be database, it can be request to a web, similar to what, for example, our latest models are doing. And then we get that information and we inject it into the prompt. We tell to LLMs that, I want you to reply this, but please use this additional data. And then we send that call to LLM. So the whole RAG is just using that additional context which we retrieve from the sources. And the sources can be different. It can be, again, like some API which will retrieve you some data in integers, text, or something, or it can be vector search. And here I was using similarity search. So similarity search works in the way that we transform the documents, whatever we want to remember, into vectors. And we store that in vector store. And then when we need to search in that, we transform the new value. It can be text, it can be images, it can be also video. But we also transform it into a vector using the same embedding model. So here we are working with embedding models, not with LLM. So we just need to transform the piece of data into a vector. It's a predictable kind of, it's always the same response for the same value of information. And we compare this new vector for what we are searching for to the vectors which we have in vector store. And then we find the nearest neighbors, the most similar responses, because here we are working with numbers. We are working with vectors, and we are, okay, which vector is similar to what we are looking for. Those vectors usually having like 500 dimensions, 700 dimensions. So those are kind of mathematically complex vectors. But in this way, we can find similar data, kind of a more effective approach for search than just comparing the exact words. So for this to work, every time the villagers were talking to each other and they finished a successful conversation, I would summarize that conversation and I would use embedding model and store that data in a vector store. Here I used OpenSearch. And then later they could reuse it information. So here, for example, I had Judy, a conversation summary, and Sam. So they kind of talk to each other, and then they have that memory of the what they have discussed. And this is how it looks. So like this is from the OpenSearch dashboards. We have embedding as a vector for a given piece of the memory which they had. So the next thing which I added is the goal. So similar to the research paper, I added, for example, for Judy, and actually Judy, the only one who had that particular idea. Judy wanted to organize a conference. And then when, yes, the goal property. So Judy wanted to convince that she wants to organize a conference. I also played a bit with the prompt, so I asked her to spread the word about the conference so that she doesn't keep it to herself, but it's important to tell about this to others. And she started talking to others about the conference. And others, for example, here she talks to Louis, and Louis started reacting pretty well. So, but it was kind of a bit of a funny situation that it was, for example, Louis was given the whole answer of where they should organize, how many people should they invite, and so on, without actually having a good conversation. So I did a bit of iteration on the prompt. And then they had a kind of a bit more normal conversation. Louis even was committing to be involved, to coordinate with local businesses and craft something. So and then, for example, the memory would he had the memory about that conversation that they plan to organize tech conference. Later, Louis shared that idea with Maru, and here I noticed that there was a bit of an issue because Maru didn't really remember the conversation well enough. She just kind of very briefly remembers that, yeah, Louis mentioned that so Louis was supportive in community initiatives. I'm like, it's not enough because then Maru would not spread that idea further. So I improved a bit of prompts, and then Maru remembered significantly more information, Stardew Valley Tech Conference idea. And then Maru brought the idea to Sebastian, and that was kind of without me doing anything. So I was just observing and running this demo and looking how fast the idea will be spreaded. And Maru brought the idea to Sebastian. Sebastian later discussed it with someone else. And Pierre at the bottom also talked, like, I don't know to whom he's talking, but heard about Judy's plan for that farming conference. I mean, it became farming conference, but it's also the idea of the game. So this is my experiment, and this is the final kind of diagram how it all worked. I am still working on this and trying to improve some additional aspects of the game. But this is how you can use Kafka, Flink, OpenAI, and vector search together. Here are the links to the materials which I used. And finally, for those of you who are Kafka people, if you would like to test your knowledge of Kafka, we have the Data Streaming Engineer certificate. It's actually totally free. And if you want to test your Kafka and Flink knowledge, go and check it out. That's it for me. Thank you so much for listening.